Hello, my name is Ray Ryan, and I'll be talking to you today about how we architect applications at Google with an eye toward actually putting them out for production. So hello. And I need to remind you, as we all have been doing, that there will be live notes being taken at the Wave at that bit.ly link there. If you can queue up any questions, and we'll see if I remember how to run the moderator application to take those off the screen, as well as from the microphone at the end of the talk. So we're going to talk about basically two things today. How does Google architect its web apps? And what is GWT 2.0 and its new friend Roo? What are they going to do to help you work that way too? This is going to build on stuff that I talked about last year at a talk with a very similar name. It seems like all of our talks have the word architecture in them this year and last year. The big takeaways from that were the MVP pattern that people keep talking about, including Daniel and the excellent testing talk he just gave here a moment ago. And to try to keep keep your app in a decoupled state. So rather than having bits of it know about each other directly, try to do your communication through an event bus, letting parts of the app post events to each other without them having to know so much about each other. Wow, this program doesn't work the way I think it does. So I'm going to whip through the next slide and pretend it wasn't there. We had a bit of a miscommunication, and there won't be a demonstration of Roo right now, but presume most of you saw or were at the keynote yesterday, where we announced a new relationship with VMware, where their very cool command line-based rapid application development system called Roo is able to generate good applications for you. I'm not set up to show it off right now, but the basic idea is that one sits down with Spring Roo, one types a few commands dictating the kinds of entities one wants to work with on a JPA persistence-based system, like say your employees and their expense reports and so on, what kind of fields they have. You press a button and then, hey presto, a good application pops out. I think in the course of various demos today, you've all seen the sorts of applications that pop out, and I've got too much to talk about, so we're going to jump past that and look into how that app is architected, why it's architected the way it is, and how you can write that way too. So let's talk about production ready. What does that actually mean? It means a lot of things here. You need your app to be well tested, secure. You need to be paying attention to what's going on when your users are using the thing. It needs to be able to scale so that you've got lots of people able to use it, and you've got at least a decent number of developers, where lots probably means more than one, able to work on the thing. As a web application, it needs to be bookmark friendly, it needs to be crawler friendly, and it needs to appeal to more than just the English-speaking fraction of the world. I'm going to talk about a few techniques to achieve all these goals. The biggest one is isolation, which knocks out a lot of these concerns right off the bat. We're going to talk about instrumentation, what you're going to actually use to do that monitoring and let yourself keep in touch with what your poor users are experiencing. We're going to talk about treating your users with love but suspicion to protect them from the people pretending to be themselves. And we're actually not going to talk about localization because we talked about it a bit actually this morning, not yesterday, during the GWT UI overhaul talk. So take a look at the YouTube for that. All right, so isolation. This is the bulk of the talk and the bulk of the time. I'm going to do a bit of a departure from some of the talks you've been seeing today and the talk I did last year. There's going to be not a whole lot of code in front of you today and a whole lot of boxes and lines. And that's in large part because the techniques I described are pretty generally useful. The code that we're providing to get you going on this, we're frankly right in the middle of writing ourselves. We've released today the 2.1 snapshot of the 2.1 release of GWT that embodies some of this stuff. A lot of it's going to change before we actually get to the next snapshot and to the releases. So we're going to talk a lot more about the concepts that we're implementing toward, and I'll try to be honest about which ones exist yet and which ones are still very vaporous. So we keep talking about this model view presenter pattern, where the idea is to make sure that The bits that are worth testing actually stay here in a presenter in the middle that is the intermediary between whatever model objects you're working with and the slow and cumbersome DOM-based view objects that actually get them in front of your user. And as I mentioned earlier, this gets discussed in really beautiful detail by Daniel Danielatos at the talk that he just wrapped up here. I really encourage you to go ahead and watch that. There will be points over the rest of my talk where I contradict points that Daniel just made. I'm wrong, he's right, and I'm going to go back and change some stuff now. But there's no time now. So on we go. So let's work our way down through this box, talk about the parts of the triad here and what our new app framework and the Roo code generation are going to do to get you there. When you're in a web app, we've encouraged you to make your model, your so-called model, a very simple object. We don't really think that Java beans with property change events and that kind of thing work terribly well. We encourage you instead to use more of a DTO for your model portion. The odds are that the object that has that embodies the things that the user are thinking about is a dumb little bag of properties. Hopefully it's the same thing that came across the wire when you made your RPC request. And in fact, that's how we've implemented the system that Roo is generating to. We've got JavaScript objects that, JSO payloads that are created on the server at request time. They make it across the wire. They're evaled the instant they reach the browser. And they don't become anything more complicated than that until as individual properties are asked for. But when you tell people who are building an enterprise app and they've got this beautiful Java model and they're writing into this cool GWT tool, which should be able to do all of their Java, and they want to share their code, that they've got to go ahead and write something that looks sort of like their model, but really not quite the same, they get all grumpy. And they say, I don't want to have to write the same thing over again. Everybody tells me not to repeat myself, and why are you guys making me work so hard? And we're going to hit on a theme here. Where possible, between Roo and GWT, we're trying to let the tools do the repetition for you. So where you are using a tool like Roo to actually define your domain objects, the guys who get to persist on the server side and who have validation logic and business logic and that kind of a thing, we'll run a tool that finds very similar looking data objects, DTOs, extracts them out, makes sure they live in a form that can make it across the wire for XHR requests, and let you work on from there. And so we have the little gear there to indicate you didn't have to write that. The tool wrote it for you, and the tool's going to do its best to maintain it for you as well. This is sort of an idealized MVP platonic model view of this type of thing. Let's look at more of what's actually going on in the code that's getting generated by Roo right now. And you'll want to hold on to these slides because I noticed one of the questions on the live wave earlier was, where's the documentation for this alleged application framework? This is it. So what we're looking at here is on the right side of the screen is what's going on the server. So we're making a request to read for a bunch of employee objects. Find me all the employee objects, or find me the employee objects from 10 to 50, because that's what's showing in my exciting new database widget right now. We provide a stock servlet, not GWT RPC, but a new ground-up implementation, in part because we're probably too prone to reinvent the world, and in part because we want to make sure that what we're working on here is going to be mobile-friendly, and GWT RPC can lead to heavyweight code. A brand new reusable servlet that will take the employee, knows about the DTO that corresponds to the employee, serialize it to JSON, send that across in the response to client-side request factory object. And when we generated the DTO that we showed you before, the employee record that comes out of, that corresponds to the employee domain object, we also generated a series of request objects for you. So your client code was able to instantiate the find me so many employees, or find me employees via this characteristic object, which correspond to static service methods that you defined at root time on the server side. I I talked through this backwards, but I'm just going to keep on talking. That we built for you, as well as the record that comes back on the other side. And so the flow in your code is, I know I need to display some stuff to my user. Quick, I'll instantiate this request object that somebody else wrote for me, fire it off, and the DTOs come back for me, and I can concentrate on my presenter code. So that's the read side of the equation, but I don't just want to read these things, I also want to mess with them. So besides the fact that we're providing you a family of request objects that correspond to the finders that you declared you wanted, we also have a general sync request object. What's going on in the bowels of our friend the request factory here is that it is keeping a, what should eventually be, but is not yet in the 2.1 snapshot, a cache of these records, of these value objects. So when it's time for me to change one of these things, we've got convenient methods for me to say, I'm a presenter and I'm working on an employee record. I know an employee record has a bunch of properties, like its name, like its boss, like its display name. I'm going to set those up, and now I want you to sync those to the server for me. The code that you don't have to write that we provide looks at the properties that you've changed. If it sees that it takes just the difference between those and the properties that were actually received on the last request, sends that delta back down to the request factory servlet, where it calls the standard service methods, lets any JSR 303 validation code fire, gathers up any errors that were reported, sends them back across the wire for display if they were there, and otherwise sends back a everything's okay type of message. At this point, another per entity class that we generated for you, a change event, is fired off to the event bus to let any other parts of your UI that are interested in employees hear about the fact that somebody, they don't know who, has messed with these things, presuming that there were no validation errors. If there were errors, no broadcast, only the person who fired off the request hears about it, they'll display the errors, and so forth and so on. And the sync requests can take care of any creation operations you need to do, any updates, any deletes. The idea is that the pattern that we've been telling you to write your apps toward for the last year, we've tried to implement the bulk of it for you. But still, all we've taken out of the equation so far are the DTOs. You're on your own with the presenters, you're on your own with the views, and presenters themselves can be kind of a repetitious thing, at least on their outside. They all kind of need a way to get their hands on the view they're going to write. You need to pass state into them, and you're going to do at least some copy-paste getting started with those. And for that matter, we're trying to generate an entire application for you. So how are we going to get into that business? What we've decided to do, or I shouldn't say what we've decided to do, it's more what we've decided to steal from other people at Google who work harder than we do and actually build applications, is a pattern called activities and the activity manager. I talked last year about a place change concept, a notion, a system to listen for browser history events and tell the rest of the app via the event bus, hey, there's been a new place that's gone on. But we didn't talk a whole lot about how to react well to those place changes when they happen. Within the company, kind of two semi-frameworks have grown up. One building very literally the place change notion that I talked about, and that turned into a framework that nobody else quite understands and has figured out how to generalize. And another written by a team that were big fans of this newfangled Android thing that was coming out at the time, and especially its notion of activities. And we're leaning towards stealing that one because more people have figured out how to reuse it. The activity name is really good, but I don't want to imply too much here because while we stole that nice activity name, the life cycle here and everything doesn't look a whole lot like what Android does, just more of the concept is the same. So just like we generated these DTOs for you to serve as your model object, when you run your friend Roo, and it generates a nice app for you that your user can navigate through to edit things and display lists of things, it's generating instances of this activity interface to actually run the show for you. What's actually going on under the hood looks something like this. You see that our friend the place change event is still actually noted there in the code that's in the snapshot right now. We have both place change floating around as sort of a primitive low-level the user wants to go somewhere concept without a whole lot of actual behavior associated to it, and its primary consumer is a new class called the Activity Manager, which is configured with a map that's responsible for making decisions like when the user goes to a place in the app called edit a record of ID whatever, we're going to instantiate this record editor activity, presenter type of thing, and start it going. So we've got a nice little life cycle going of the event bus notifies anybody interested in the app, hey, the user's at a different place now. Any activity managers that are listening, first see what activity they're running at the moment, tell it to stop, go away, you don't get to play anymore. And they look at their configuration and find the next activity to instantiate or to reuse, probably instantiate, and tell it to start. And then that's it. Nothing else goes on at this point until the activity has had a chance to fire off an asynchronous request back to the service to pick up whatever state that it needs, to render itself, to set up a widget that it may have been handed. After this asynchronous trip, the activity manager gets a call back. Here's my widget. I finally have something to show you. Display it to the user now. This is all a long-winded way to say that the activity is a nice little mini application within your application that gets told by somebody, you go now, makes an asynchronous request to get its state. With any luck, it's going to hit a cache on the way and not actually go over the wire the second or third time that it's called and short circuit right away, but maybe it won't. But asynchronously, it will finally call back and say, here's some UI that is interesting for me, and I'm going to present it. I'd like you to present it for me now. Because the activity is isolated like this, all it knows about is that it's time for it to turn on, do what it knows how to do, and then let somebody else handle actually putting that state, its view state in front of the user. It can run in nice isolation. It's really easy for me to write a mini application that does nothing but test my individual activity. If I want to really focus on the expense report editing logic in my app in an interactive way that I can refresh to the browser without rebuilding my entire app, I've got a way to do that. If I want to write a nice little isolated JRE unit test, I've got a nice unit through which I can do that as well. That's the basic point of the activity. It's a standard pattern for your presenter code to actually adhere to so that somebody else can be in charge of actually firing the things up and firing them down. As I started to imply here, because that activity is so self-sufficient, because it's not relying on other parts of the app to have actually made upstream requests and so on, it's something that can run by itself, and that makes it a very bookmarkable and a very crawlable piece of your application. Each activity is expected to be fired into existence as a side effect of a browser history event when the user clicks on a back button, a fourth button, maybe hits a bookmark, and is really expected to be very self-sufficient. That means that it's very bookmarkable. Somebody's going to go to the example.com pound report number 1 and the activity should be able to take care of everything from there. If you've been paying attention to what's been announced on various blogs and such over the past year, you'll know that Google now supports a convention, a way for AJAX applications to declare themselves to be crawlable. So if you've written your app in this bookmarkable manner, and you introduce a little bang after the hash sign in your bookmarkable URL, you're suddenly giving a clue to the Google bot that you are also a crawlable AJAX app. I'm not going to go into the full crawlability lifecycle here because that's covered in great depth at the link that you see down here. But by building your app in this style, you're a good portion of the way to making yourself available to that kind of indexing, getting more hits and getting more users. Follow the link for more info, please. So we've got our DTOs being generated. We've got our activities being managed for us and the initial version of them having been written for us by a code generator. We still have this view code to write. And what you're shooting for with your view code is something that's too boring to write and too boring to test, which means it's probably not going to be a whole lot of fun to write. So we're going to generate those for you as well. And we're going to use a new GWT code generator to support you along the way, a new editor support interface whose job is to do a lot of the data binding activities for you. And coming up here, we have about the only code slide that you'll see in the presentation today. We're shooting for something like this. Imagine that you're looking at the code behind a view that's going to take an employee record, that's going to put that in front of your user with the name field and a name text box and the display name in the display text box and so on. When you're finally writing that code, that comes down to a lot of employee get name, employee text box dot set value dot employee record dot get name and that kind of stuff over and over again. When it comes time to pull that information back out of the UI, you write a lot of the same get methods. Text box dot get value and set it into the record, and it's rather tedious. It gets even more annoying when you get to the point of having validation errors that you need to display to your users. The odds are that most of them, you've tried to do some of them client-side, and we do intend to automate a lot of that client-side validation for you. Not in the snapshot yet, but we'll get it there. But most of the interesting validation, especially any business logic validation, is going to happen back in the server, at which point a request will have been fired, a response will come back, and you'll have a mass of errors tied to particular fields, which you then have to route to show to the appropriate bit of UI. The same generated class should be responsible for noticing which errors respond to which fields, getting them tied to the appropriate bit of the UI, and put the cute little red flag at the right spot. The support class is also very capable of letting you know if anything actually has changed here, so that when you want to write your logic for, say, your save button, and whether that should be enabled or disabled, there's an automated way to ask, has the user actually typed any values that don't match the backing model object that I'm displaying here right now? You've got an easy way to know whether you need to warn the user, hey, you're about to leave this part of the app, and throw up a warning about the changes that they're about to lose. So this is when I hinted at the beginning that if there are contradictions between what our friend Daniel said in his testing talk and what I've said right now, here's a spot where I suspect that we are aiming at the wrong layer. The way the code is generating itself right now, and what I'm implying here right now, is that you've actually got a fairly complicated view class that knows about your value object. You can cram a value object into it, and it can do all kinds of display, let the user mess with things and pull it back out again. The class does wind up actually being very simple, provided you're actually using this support object here to do all the fairly complicated but mechanical marshalling in and marshalling out. Maybe that's the right space, maybe that's the wrong space. It may turn out that by the time we ship this monster in GWT 2.1, our friend the data binding class has moved up into the presenter level. Maybe, maybe not. But that's the approach that we're at right now. Okay, so we've talked about isolation. And we've hit a lot of the points that we said that isolation would cover for us. We're well tested now because we can do all kinds of testing on our nice isolated little activity objects. We've got lots of developers going because my activity doesn't know anything about your activity. They're not very likely to have side effects on one another. We're bookmark friendly. We're crawlable because each of our little activities can run in isolation from everybody else. We haven't really gotten to the lots of users promise, and none of this actually feeds into that. Really, I've sort of crammed that one into the isolation theme because I liked the way it all shaped up and wanted to look at it together. The way that we're getting there in the apps that we're generating with Rue, or that we're deploying on App Engine, is by encouraging you to work in against a subset of the JPA feature set. The app that you saw generated today, or saw generated and demonstrated at the keynote yesterday, was a proper JPA app, can be deployed to any JPA backend, and that includes the App Engine. And the reason that it's able to be deployed to the App Engine is that it stayed very far away from relationship reference features of JPA. What App Engine provides today, as you're probably familiar with, is a Google-specific persistence layer called the data store. And the data store can scale up to scary big numbers of records and maintain all kinds of speed and responsiveness. But the way that it can do that is by being very restrictive about what kinds of relationships you can have between the records within an application. If you want to maintain that kind of scale, well, the way I should put it is when you're writing one of these apps, you kind of have a choice. Do I want something that's going to be super portable and super scalable to Google levels? Then there's features of JPA that I should stay away from. And our intention is to have Rue able to keep you on the guidelines, keep you within the boundaries for working to that scale if you want to. Or if you decide that you want to be able to deploy anywhere except GAE because you just want things to be scalable enough, but you're not really going to be doing millions of users and billions of records, just the usual hundreds or dozens or thousands for an enterprise app, go ahead and use the rest of the features. So regardless of which of those styles that you choose, persistence side for your entity objects, and let me say a little bit more about that. When you're making this choice between using real references or not server-side, what you're actually choosing between is, does my employee record include a boss field that is of type employee, or does my employee record include a boss field that is type long, the ID of my other related boss, my other related employee? Am I going to manually maintain the code for navigating from employee to his expense reports and so on, or am I going to use the features built into JPA to make this kind of thing more convenient like I'm used to? That's all server-side decision, that's all server-side cumbersome code, some of which we hope to actually automate for you on the Rue support. Client-side, it doesn't make a whole lot of a difference. Client-side, you pretty much always want to be working in this record doesn't accidentally pull along that record and accidentally pull along his related records and their records and so on, kind of transitive explosion nonsense in your web browser code. That's why we pushed the notion of going to DTOs in the first place. By not trying to bring over your server-side business objects into your browser mechanically without thinking about it, you're never going to be accidentally pulling across the entire object graph when all you really wanted was to know somebody's first name. So whether your server-side code is working with full references and pointers to pointers to pointers or not, client-side, your code will already have been written in the style of, okay, give me the employee, okay, now give me the related records, okay, give me this, give me that. So you actually have a lot of flexibility in about where you're going to choose to deploy, regardless of which style you choose to write in. So I think I've exhausted isolation, talked about that as much as I really can. But we still have other things that we need to do to have a production-ready app. We need to instrument it. We need to know what our users are actually going to be doing. And there's sort of three things that we need to do to get there. We need decent logging. We need stack traces so that when things go wrong, we have a hope of figuring out what actually happened. And we need a pattern that we're referring to now as user actions. Again, something that I'm stealing from several very successful Google teams. And let's go into more depth on each of those. So logging, first and foremost, is a pretty obvious thing that has been sadly lacking inside the GWT toolkit proper for, well, ever. There's a very popular package that's outside of GWT, the GWT log package. You can find it on code.google.com. It's in wide use within Google. It's in wide use externally to Google. A guy named Fred Sauer, who now actually happens to work for us, is its maintainer. As of GWT 2.1, you no longer have to go outside of GWT in order to get what should be a fundamental service of your app. We actually have, honest to goodness, Java util logging emulation in GWT as of this snapshot, and it'll be ready for prime time as 2.1 actually ships. And the difference between the Java util logging that's moved into GWT 2.1 and Fred's excellent package is that we actually were able to provide the standard Java util logging API rather than having to make some compromises. Fred's isn't an exact match, and for the very good reason that at the time that it was written, there was no way you could implement to the standard Java util logging API, which encouraged you to have logger objects around to talk to directly rather than calling any static methods. There was no way that the GWT compiler of the day could completely dead strip code written in such a style. if you decided you wanted to turn a knob and make sure that what deployed to your users actually wasn't going to cause them any trouble. Somewhere along the way, the GWT compiler got a lot smarter. I'm not sure exactly what happened, but when we sat down to revisit this problem and see if it was still the case that as we had been convincing ourselves and preaching to people for years that you can't do that anymore, it just wasn't true. My office mate, Una, did some tests and very empirically showed that no matter what kind of stuff you throw at a logging object these days, if that logging object is instantiated through a code path that could never have returned anything but null, it'll simply evaporate. I'm hand-waving a bit here about what the actual coding patterns are that you need to follow in order to make sure that that kind of thing happens, but it's fairly straightforward. If you want to play with this today, it's in the snapshot. Documentation will follow, showing kind of do's and don'ts about how to work with these things to keep them safe, but it'll all be there. So anyway, long-winded digression. What you actually want to do with this client-side logging to keep an eye on what your users are up to is keep a buffer of the logs accumulating on the client side. It's up to you to decide how much you actually want to hold on to, how much you want to send down right away, but there's no reason to be sending an RPC request every time any kind of a log line happens. Kind of the meta point here is just because you can set a knob and dead strip all of your logging code if you want to, there's no particular reason that you need to dead strip everything if it's going to be useful to keep an eye on the health of your app. Maybe you're just going to turn the trace level knob up to the info level knob or the super info level knob, something like that. But with each log line that you leave in there, you accumulate them all server side, and you listen to our friend the event bus for announcements that there's a request that's about to hit the user. Something I meant to go into in the request factory section of this that I forgot about is that it is our intention to have the request factory provide both batching and caching services for you, so that while your nice little isolated activity objects are firing off the request for this and the request for that and so on, they're all going through a nice centralized point in that service object, the request factory service object, so that with each tick of the event loop, we can send an entire batch down for you. And that gives us a nice train that our accumulated logging statements over the last event loop tick or longer, if that's appropriate to us, can go down into a single, hitch a ride along that same ride. Oops. Yes, there's more I want to say on this, but we come back to it later, so I won't confuse myself now. So, logging, coming now, but you can use it today in the GWT log package, and you probably already are. Stack traces. You probably know that you do get some kind of a stack trace on most modern browsers with one glaring exception. But the interesting thing is that you actually want to get this information to the server. You've actually had support for doing that kind of thing in GWT for a little while now. I believe with GWT 2.0, if you rummage around, you'll find a convenient object called the HTTP Throwable reporter. And his job in life is to take a throwable and get it to the URL of your choice in a simple little JSON format that you can then start logging server-side and keeping track of yourself. GWT log, the package that we were just talking about, comes standard with a remote logging service, which is also capable of doing this kind of thing. Grab a throwable, stick it into a logging statement, and it'll reach the server at some convenient point. What people might be less familiar with is that it's possible to make these exceptions actually useful. What happens normally with GWT compiled code is lots of good obfuscation happens. We're squeezing all of the juice out so that your users don't have something bloated. But as a result of that, if you're using GWT log, if you use the throwable reporter to capture these exceptions that happen in production time and send them down to your server, you get teeny little gibberishy sort of symbols that it's kind of hard to get any information out of. With GWT 2.0, it is possible to resymbolize these obfuscated stack traces. We've actually even documented that fact if you follow the URL that's on the screen there, and my apologies if it's too small to read, but it is what it is. I'm sure that when you scroll back over the YouTube video with a magnifying glass, it'll be no problem. If you follow that page, you'll see a recipe of how to get this all done, but it is rather minimal documentation. We'll try to follow up on this and get you a more repeatable recipe. And it is also, of course, our intention that the apps that get generated by the Roo tools will have this kind of stuff configured for you already. It's not there yet, but it is on the roadmap and should be part of the 2.1 release. But these stack traces, besides being obfuscated, although now you know how to solve that problem, are also kind of granular. If you even have the things, and a sizable portion of your users will be using browsers that don't provide them, the best they're going to get you is function level, method level information. If you've got a an exception that is thrown inside of a method that's 100 lines long, you're going to be told, it was that method. That was the one where the problem was, but you've got no line number information. There's not a lot you can do at that point. That problem also has been as solved as it can be in GWT 2.0. There's a new knob that you can turn on called Stacktrace Emulation. This gets you any kinds of exceptions at all in browsers that don't actually provide stack traces. And it can be set, I've lost track of how configurable it is. At one point the plan was to let you decide how much emulation it does. I know that if you just turn the thing on by setting this property in a GWT.xml file, we actually will keep track of line number information, do all kinds of crazy stuff behind the scenes to give you full, useful stack traces when they're thrown. The downside of doing all of this is it does make your app slower, and it makes your app fatter. Not as much slower and fatter as you might fear. I think the speed numbers that I recall are on the order of a factor of 2 or so. The code bloat was tens of 20%, something like that. Don't quote me on that, I'm making it up. It's enough of a difference that you don't really want most of your users working like this, but it's small enough that you might be tempted to actually sneak a few of them out there and make it available to people. One technique that you might do is compile a version of your app that you can point your users at that has the emulation put in. So you get a report of this terrible thing is happening when I run my app. You can shoot a response back saying, well, could you run the app and add to it this nice little debug flag for me, and we'll see what you get, or I'll watch my logs as it goes on. And you can use this configuration set up in your GWT.xml to make that possible for your users. You could use more complicated approaches to actually define percentage experiments. What one team does inside of Google, I believe, they said they were going to, is for their Internet Explorer users who might meet certain other certain other characteristics, I don't remember exactly. They'll set a percentage of interesting users to a version of the app that actually has the full instrumentation compiled in like that, and collect the exception reports that appear there, and so they actually have some picture of what's been going on without slowing down everybody in the world as they do it. And again, once you have your hands on these exceptions client side, it's really not at all hard to let them trickle back to the server, log them, start running graphs on them, that kind of a thing. So, instrumentation, the final piece of the puzzle there are user actions. Here I am at my most hand-wavy. This is code that has basically been designed and been discussed among teams that use this technique inside the company. There's nothing implemented yet in the snapshot. Monday morning, the groundbreaking begins. But the simple but tremendously powerful idea here is that you associate portions of your app, bits of your app that the user can touch, with unique strings, just something to identify them. Link elements, buttons, tab items, that kind of a thing. It's really quite simple, in fact, to set up your system in such a way that you can have these strings embedded in the UI.xml files that actually define your user interface, so that when I use my magical user action link widget instead of the normal stock link widget, I can add an attribute that says, this is user action, the user has asked to edit something, that sort of a deal. Such instrumented widgets, when the user actually clicks them or whatever, make an announcement to the event bus, because we like event buses. Somebody else is listening on the event bus to hear whenever a UI element declares the user has started action X, and they start the timer. He's also listening to the event bus for RPC events that might happen as a side effect of this user action having been started. So employees are requested, syncs operations are made, that kind of a thing, and keeps the timer going. As responses are received over the next few microseconds, or well, hopefully microseconds, The activity manager is listening for a paired event from the request factory announcing, okay, I've gotten the responses for this. When it sees all the responses, matching all the requests that happened after that the user did something, event was fired, the timer shuts down, and we log something. And we're back to taking advantage of our friend the logging system to accumulate our user action logs client side and trickle them down to the server as they're actually needed. With all of this stuff, we keep talking about accumulating things client side, letting them ride the batch back down. It's up to you where you want to make the trade-off of talking to the server too much and bothering your users and talking to the server too little and losing information. The team that's been particularly pioneering with the user action pattern started off keeping, I think, their basic heuristic was whenever we see a request going down, we'll flush our accumulated logs of user actions and whatever else. And if nobody's asked the server for anything in 30 seconds, we'll fire off a request of our own. That proved to be too long. A lot of information was being lost. It was still hard to debug things. They're now at the point where I think that if no user action happens for 3 seconds, they'll actually go ahead and force a request to go back to the server. No users have noticed. It doesn't seem to impede performance at all. And they wind up with a very sophisticated description of what users are up to, and in particular, what chain of events led to perhaps the exception that got logged on the next thing after the user action log was happening, or it got intermingled in with the user action log. One other interesting thing I'd want to point out here is this team made the conscious choice, rather than tying these user action descriptions to activities. You remember activities? We talked about those at the beginning. Rather than deciding that our nice little isolated activities would be the unit of, hey, the user's doing something, let's make note of that and then start logging requests, they wanted something a lot finer grained. Once I'm within an activity, I could be exposing menus, hiding menus, I could be moving focus between things. A lot of stuff that doesn't have anything to do with browser history or states within the application. And so they chose to actually make this a very kind of micro instrumentation sort of feature. It's worked out nicely with them, and they've got one of the most beautifully designed apps in the company as a result. I mean, not only can they keep an eye on the quality, the exception reports and bugs that are happening, they also have a good notion of what features get used, what features don't get used. They're able to discover that this really cool and important feature that we just implemented and spent a month of engineering time on, nobody can find it and nobody clicks it. Maybe it's time to move that around. The more information you have, the more information you can react to. So that's monitoring. Now let's talk about suspicion. I don't have a huge amount to say here. I just want to point out a couple of features that have found their way out from behind the curtain recently. What this is all about is guarding against cross-site attacks. And there's a kind of a cute little thing that sort of snuck into, let me see. What did I say? Oh, I wrote it down there. I don't have to remember. It's making its debut in GWT 2.1, and that is our habit of sending down on every request in GWT RPC a header that tells you the strong name of the particular GWT permutation, your client code. Excuse me. We set a header on every request with this magic name XGWT permutation. The header is actually there to help in Stacktrace deobfuscation. In order to know what symbols are actually there in the Stacktrace, you have to know what flavor of your app was compiled. But a clever person noticed, hey, this header is going down. Only XHR requests are allowed to set custom headers like this. XHR requests are only allowed to return to the domain from which the code originated. So it's difficult. Not quite impossible. I think versions of Flash will let you get around this, but darn difficult for malicious code loaded through a script tag or by accidentally rendering some user-generated HTML to actually set such a header. And so the GWT servlet that actually fields GWT RPC requests by default now will refuse any request that doesn't have this header set. If that's causing you trouble for any reason, it's very easy to turn that protection off. It's also a nice point at which you can try to get a little bit more clever about what kind of headers you're looking for. It's a nice override point in the app, but it's there now. You're one step closer to safe. Something else that has also appeared in the last 24 hours with very little fanfare is I guess it could call it a framework, a new framework called Safe HTML. This is something that we've been using internally for quite a while now, and it's a system for, well, I'll talk about what kind of a system it is, but let's talk a little bit first about where you can find it. The Wave team, among many other things yesterday, while announcing that they have opened themselves to all comers, also open sourced a whole lot more stuff, including a full Wave web-based client. They took their Fed1 client, they've made a web version of it. The code is totally open for you to mess with, including a lot of the interesting display code that Daniel wrote. And in order for them to open source that, they had to open source our nice little HTML scrubbing system, Safe HTML. So something that we've been hoping to kind of get into GWT at some point, 2.2, 2.3, is out there now because another team got impatient. It's there for you to find rummaging around the Wave open source code site, and we'll incorporate it into GWT a little bit more robustly at 2 point someday. So what Safe HTML basically does for you is it tries really hard to discourage you from ever using the set inner HTML call. And the problem, or the set HTML on our widget, set inner HTML on DOM elements. The problem with that call is it by God, it builds DOM. And it can build script blocks, and it can do all kinds of things. And there's a really good chance that when you're calling it, you forgot to make sure that what you're rendering there didn't come from your user, who intentionally or accidentally wrote /script, rummage for my data, and send it off to somebody else, and What the Safe HTML framework does is it introduces an interface called Safe HTML, which promises that I am some HTML that somebody very clever carefully assembled for you in a way that didn't come from user sources, that doesn't accidentally include extra angle braces to break things and so on, and you can just go ahead and plug me in someplace. It doesn't yet, but by the time it's incorporated into GWT proper, it will come along with a revamping of our widgets to deprecate set HTML methods and replace them with set safe HTML methods to encourage you, when you do actually need to build bits of HTML, use a convenient builder object that knows how to snap these things together without accidentally having rendering side effects on you. It also includes a runtime, so that's our friend Safe HTML builder, meant to be more of a semi-compile time type of thing. We have the simple HTML sanitizer that comes along with it for when you actually do need to take some information from the user client side and run it through some sanitizing before you put it in front of them. That's the basic idea of it. But it's, like I said, it's not in GWT yet, but it's hugely useful, it's hugely proven, and I think you'd be wise to go ahead and start grabbing it and using it yourself. So that's about what I had prepared for you. Just to recap, this is what we think production ready means. And I think the main way that you get there is in large part by keeping your bits of the app isolated from one another. You achieve the scalability across lots of users if you want to do monstrously big things on App Engine by similarly isolating your entities from one another on the data storage side. This gets you crawlability. This gets you being bookmark friendly. It might get you hits from the search engine of your choice. Your app needs to be monitored, it needs to be instrumented so that you can take care of your users and see what they're actually up to, get some eyeballs in there. And finally, your app needs to be a little bit wary of just what your users are getting up to. And of course, with our new relationship with VMware and Rue, which I'm tremendously excited about, you shouldn't have to be working so hard to do all of this stuff. We think that we can let you get a good part of the way there by generating an app that sets you off in good habits and good style, an app that we can maintain at least a good portion of the plumbing for you as your app grows, and like that, a third point that I forgot that I wanted to make. So that's it. Thank you. So I'm going to try to figure out how to do the moderator thing, but I screwed it up last time, and that was with a program that I understood. Give me 1 second to try to get this going, and then we'll take questions from the microphones. That doesn't work. Does that work? Copy hyperlink URL. Oh, that's Speed Tracer. Ah, cool. I'm still not mirroring, am I? Okay, and while that comes up, hi.
Quick question about safe HTML. Do you know if it has any support for kind of like allowing basic HTML?
Say that again, please.
Do you know if safe HTML has any support for allowing basic HTML, you know, like image tags or the bolds and italics from the user?
It's more the idea that you will use the safe HTML builder to put together this stuff like that, rather than. I'm pretty sure that the sanitizer is not so ambitious to try to distinguish safe from unsafe tags that user might provide.
Gotcha.
I think it's more about making it easy for you to assemble that kind of stuff as you need to.
Gotcha.
It also has a mini compile time templating system built into it that I didn't go into.
The assumption is you've already sanitized on the way in. The user's input.
Right. I'm trying to think of the correct answer to that. It's more the assumption, I can't remember the exact answer there, but it's pretty well documented, unlike a lot of the stuff we discussed today.
Thanks.
Okay. Hi.
Hello. So if you generate that much, do you actually need to generate it? So you can use it at runtime, like maybe pass XML and then use that XML at runtime. It doesn't generate code at all.
We tend to find that the more we try very hard to do as much at compile time as we can. It's sort of one of the central tenets behind how we approach this stuff. The more we do stuff at runtime, the more we find the app gets bigger and the app slows down. That's why there's no reflection in GWT. That's why there's no introspection. And while we're generating a lot of code here, this is every line of code that we generate is something that the compiler can consider whether you are actually executing it, how you're actually executing it, can inline things, can throw away unused portions, and so on. The more flexible we leave things at runtime, the more we have to leave there just in case you call it in a way that we weren't able to tell if you do or you don't. In fact, the code as it ships in the snapshot right now probably errs a bit too far onto the runtime side. Something that I didn't go into here is the request factory code is set up right now so that you can, when you ask for a particular record, you can actually indicate, and here's the set of properties that I want you to include with this record as you bring it back over. Right now, that information all happens at runtime, and we're thinking that was perhaps the wrong move, and that we should turn that to more something gets declared more statically, more declaratively, so that we're not being forced to keep so much information around for you at runtime. Did I answer your question?
Yeah, almost, yeah, but isn't that code bloat? At the end, you have a lot of code that it's always almost the same. So if you don't generate it, there is a chance the application will be smaller and maybe faster.
You'd think that, and we shouldn't be completely cavalier in what we generate, but typically sorry, I'm trying to understand I hereby promise to answer the online questions offline after this, but I can't figure this thing out. Typically, the code that you generate, the compiler will get rid of it if you don't actually use it, and the odds are that what you're generating is something that you intended to present there in the first place. For example, right now, the stuff that we've shown off here is not very configurable. It does, in fact, look at every entity you've defined server-side and generate UI for you for that and RPC for that. Our hope is that we can make that a little bit more selective. So while it's easy to generate something that will export everything, you can take a little bit more control of it and say, well, here's the 20% of my entity set that I actually want to make visible to the client. Go ahead and do that. So we will not be quite so stupid, but I still think compile time rather than runtime is the time to be doing that. Hi.
Hi. So if you think of a big GWT app like AdWords or Wave, it seems like a Roux-generated interface isn't going to obviously hold up very far into the development of an app like that, right? Because it looks like it's really for CRUD-style interface.
Absolutely.
So in that case, can Rue just maintain like those DTOs and those event objects for us and let us do the UI, or is it basically all Rue or no Rue?
No, it is very much the intent that Rue, and it's how Rue is working right now, is it's kind of generating two layers of stuff for you. It's got a set of classes that it treats as very much mirrors, reflections of what's going on the entity side that it will keep updating and keep updating. But on the first run, it also generates a bunch of UI scaffold that it puts there for you for the first time, and then it's not going to touch it again. And one of the most interesting challenges with this, and something that we've having to learn from Ben and the guys at VMware, is just how to architect this thing. So not only is it something that you can reuse, but architect it so it's something that the different bits are isolated from each other, so that, for example, the entry point that is configuring all of this stuff to put in front of users in the first place is isolated from, say, the list of all possible entity editing places that Rue is going to update and extend and extend and extend, so that I can mess with the overall application structure while Rue can keep maintaining the plumbing for me.
So if you're going to build something like AdWords, you could use completely custom UIs, not even use any of Rue's generated UIs at all, but still get the automatic generation for the DTOs. And
that is very much the intention. The place where it's weakest in the snapshot implementation right now is Rue is generating for you the list of possible locations within the app, the place objects, and we've screwed up making that something that you can extend without actually having Rue clobber everything you do or taking Rue totally out of the picture there. So we're still kind of working on that, and I think it'll all settle in as we get a real history implementation.
So you would intend
that's the goal.
Yeah, so you'd intend that if someone's not using Rue, they would still use the activity paradigm that you shared with us and all that
Absolutely,
stuff?
absolutely. There's nothing at all Rue specific about the activity manager,
Or
about the
Request
activity
Factory or
framework. Request Factory, all of this should be usable without Rue. It's a bit laborious to configure as things are at the moment. I think we can make it more concise so that while it's convenient to get it generated with Rue, you should still be able to work with it by hand, but we're getting there. Once you get above that level of the request factory into the editor support and all this kind of a thing, we want very much for this all to be usable whether or not you're working with Rue. Just like the new data widgets that we've been discussing, the cell widgets that we've been discussing in other forums, can work very nicely with this world, but don't require it. We want the other layers to work nicely together, but not require. We don't want to dictate to you absolutely every layer of how you work with your app.
Thanks.
Mm-hmm. Hi.
Can't wait for 2.1. Since 2.0, we've started using code splitting, and our application has grown pretty big. Now we're thinking of actually hosting our application, like at least the static part, on a CDN type system where the static files can be loaded from a different server.
I'm
But
sorry,
now,
I'm having trouble understanding you.
Oh.
You've been using code splitting since 2.0.
Since 2.0, and our application has grown pretty large, and we're hoping to actually host the static files on a CDN, something like a static.domain.com. And do you have any thoughts or best practices around?
Ray Cromwell would like to take the microphone and answer that for you, which is good because he's much smarter than me.
We kind of had run into this problem at Google. I think AdWords was doing the same thing. They wanted to host the static resources on a different server. So Lex Spoon, who is the architect of code splitting, just recently came up with a thing called the cross-site fragment loader linker or something like that. I can't remember the actual name, but it's specifically designed for this use case so that you can put your static resources on a CDN, but keep the code split compiled artifacts on a different server. So that definitely will be supported. I don't know if it's in 2.1 or if it's in trunk or.
I think, don't quote me on this, but I believe that everything that's in trunk right now is destined for 2.1. It's not all in the snapshot, but I don't believe that we've yet set the boundary for what's going in and what's going out. There's also been talk, and this is not something that's being under active development right now, but Bob Votter keeps looking for an excuse to implement it. We have our client bundle now, which is able to compiling all of your resources and so on. And what he'd like us to get to is take that to a step further and build what he calls the server bundle, where you're able to indicate a bunch of resources that still are strongly typed and that your code has API access to, but which we don't actually fetch until you want to use them. It's a little orthogonal to what you were asking, but same kind of idea.
Yeah. All right, thank you.
Yep. I think this is the last question.
Hi. So activity managers, I looked at some Rue-generated code yesterday. It wasn't clear to me whether an activity manager lives at a global level where one listens for all activities or if they're kind of localized.
Typically, one has a global activity manager, but it's not a requirement. And in the scaffolding app that we're actually generating right now, we actually have two of them. So all an activity manager is somebody who's able to listen for place change events, history events, figure out what's the appropriate presenter and view to put in front of the user and put them there. And there's no reason that you can't have several of those working at once. What we actually still need to do is figure out how to actually tie all of this into the history mechanism and let them persist their state that way without stomping on each other, without requiring each other. Stay tuned.
All right.
And my clock is up, so I think I have to get off the stage now. Thank you all.